Have you ever made decision based on gut feeling but wished you had proof to back it up? Maybe you believed your new ad campaign would boost sales or that a new diet or treatment actually works better than the older one. But how can we know if what we are seeing is real or just random chance? That's exactly where hypothesis testing comes in. Foundation of statistical decision making in business, healthcare and research. It is how analysts, scientists, and decision makers move from assumptions to evidence, using data to test ideas, validate results, and make confident data driven decisions. Welcome back to Shital's Data Days, your one stop destination for simplifying data, analytics, and visualization. In this video, we will break down hypothesis testing step by step. You will learn what hypothesis really means, five-step testing process every analyst follows, real-world example to tie it all together, key concepts that make or break a reliable test, how to interpret p-values and significance levels, choosing right test, common mistakes to avoid, and wrap up and recap. So let's begin by understanding core question. What exactly is hypothesis and why does it matter in data analysis? Let's start with fundamental question. What exactly is hypothesis testing? In simple terms, hypothesis testing is structured process of using data to evaluate claim or assumption about population. It is a statistical framework that helps us decide based on evidence whether an assumption should be accepted or rejected. For example, company might claim that its new advertising campaign has increased average sale. Hospital might believe new drug shorten recovery time, or web analyst might suspect that new website design leads to higher conversions. In all these cases, we begin with statement, an idea we want to verify, and then use data to test whether that claim is likely to be true. Technically, hypothesis testing evaluates two competing statements about population parameter, like a mean, a proportion, or a difference between groups. First is null hypothesis, written as H null. It represents default or status quo, assumption that there is no effect, no difference, or no change. And second is alternative hypothesis, written as H1. It represents challenger, claim that something new or different is true. Let's take an example. Suppose a company claims its batteries last 10 hours on average. That's our null hypothesis, H null, mu equal to 10 hours. If we believe batteries actually last less than that, our alternative hypothesis would be H1 mu less than 10 hours. Think of it like courtroom. Null hypothesis is defendant, assume innocent until proven guilty. Alternative hypothesis is prosecution, presenting evidence to challenge that assumption. Our goal is not to prove null hypothesis false with absolute certainty. Instead, we use data to judge whether evidence is strong enough to doubt it. In other words, hypothesis testing doesn't give us proof, it gives us probability based confidence. Now that we understand what hypothesis is, let's walk through step by step process of hypothesis testing. Logical path that turns an assumption into data driven conclusion. Step 1. Define hypothesis. Every hypothesis test begins with two statements. Null hypothesis, H null, default assumption that there is no effect or difference. Alternative hypothesis, H1, challenger, claiming there is an effect or difference. For example, imagine an e commerce company that claims its new website design does not affect conversion rates. That's your null hypothesis, H null. Conversion rate remains same. Alternative hypothesis, H1 would state new design does change conversion rate. In short, you are setting up competition between two ideas and data will decide which one wins. Step 2. Choose significance level. Next, we decide how much evidence we will require before rejecting null hypothesis. This is called significance level, often represented by alpha. In most cases, alpha is equals to 0.05, meaning we are willing to accept 5% chance of rejecting null hypothesis, even if it is actually true. In simple terms, we are setting threshold for how confident we want to be before making our decision. Think of alpha as our risk tolerance, how much uncertainty you are comfortable with in your conclusion. Step 3. Collect and summarize data. Once hypothesis and confidence level are set, it's time to collect sample data. Depending on question, This data could come from surveys, experiments, or system logs. We then calculate test statistics, a numerical summary that tells us how far our sample data is from what we would expect if null hypotheses were true. Different tests use different statistics. For example, Z score for large samples or T score for smaller ones. Step 4, calculate p-value. Next comes most talk about part p-value. It tells us probability of observing our sample result or something more extreme if null hypothesis were true. Smaller the p-value, stronger the evidence against null hypothesis. If this probability is less than our chosen alpha, say 0.05, it means our data is too unlikely under null and we have reason to reject it. Suppose your p-value is 0.02. That means there is only 2% chance of seeing your result if null hypothesis were actually true. That is strong enough evidence to doubt null and favor alternative. Step 5, make decision. This is the moment of truth where analysis turns into insight. If p-value is less than or equal to alpha, we reject null hypothesis, concluding there is significant evidence for alternative. If p-value is greater than alpha, we fail to reject null hypothesis, meaning we don't have enough evidence to claim difference. Notice, we say fail to reject instead of accept the null. That's because not finding evidence against something doesn't mean it is necessarily true. It just means our data wasn't strong enough to disprove it. Step 6, draw insights and communicate results. Finally, we interpret what result mean in context. Hypothesis testing is not just about numbers, it is about decisions. If e-commerce team finds their new ad campaign significantly increases clicks, they might scale it across all platforms. If hospital finds no significant difference between two treatments, they might stick with existing one. Real power lies in translating statistical results into strategic action. Now that we know how hypothesis testing process works, let's bring it to life with real world example. Something every business can relate to. Imagine you are data analyst at an e-commerce company. Marketing team recently launched new digital ad campaign and claim it has increased average daily sale. To verify this claim, you decide to test it statistically, not just rely on intuition. Our null hypothesis, H null says campaign did not change sales. Average daily sales remains same as before. Alternative hypothesis H1 says campaign increase average daily sales. So we collect data from two time periods, sales figures before and after campaign. We decide on significance level of 0.05, meaning we are willing to accept 5% chance of wrongly rejecting null hypothesis. We conduct t-test comparing two sets of sales data. Output shows p-value of 0.03. Since 0.03 is less than 0.05, we reject null hypothesis. This means there is statistically significant evidence that new ad campaign did increase average sales. In simple terms, data backs up marketing team's claim. So now we understand logic from forming hypothesis to interpreting p-value. But remember, like any tool, hypothesis testing works best under certain conditions. In next section, we will explore key concepts that make or break reliable test, including type 1 and type 2 errors and importance of statistical power. Before you run any hypothesis test, it is crucial to understand few key concepts that determine whether your results are actually trustworthy. First is type 1 and type 2 errors. These are two possible mistakes we can make when interpreting test results. Type 1 error happens when we reject true null hypothesis. It is like declaring new drug works when in reality it does not. We call this false positive. Type 2 error, on other hand, happens when we fail to reject false null hypothesis. It is like saying new medicine has no effect when in fact it does. That is false negative. In simple terms, type 1 is false alarm and type 2 is misdiscovery. Both are important, but which one matters more depends on context. In medical research, avoiding false positive might be critical. In business, missing real effect could mean lost opportunity. Second key concept is statistical power, probability that your test correctly detects true effect. High power means your test is sensitive enough to spot real differences when they exist. Power increases with larger sample size, lower variability, and higher significance level. In other words, stronger your data means more confident you can be in your conclusion. So, type 1 and type 2 errors remind us that every statistical test carries some risk, and statistical power ensures that when something real is happening, your test can actually catch it. Now that we understand foundation of reliability, let's tackle one of the most misunderstood part of hypothesis testing, p-values. P-value is often most quoted and most misunderstood number in statistics. So, what does it really mean? P-value tells us how likely your sample results are, assuming null hypothesis is true. It measures strength of evidence against null hypothesis. For example, if you get p-value of 0.03, it means there is only 3% chance of observing results this extreme if null hypothesis were true. Smaller the p-value, stronger the evidence against null hypothesis. We compare p-value with preset threshold called significance level, generally 0.05. If p is less than 0.05, we reject null hypothesis and say result is statistically significant. If p is greater or equal to 0.05, we fail to reject null, meaning we don't have enough evidence to claim difference. But remember, not significant does not mean no effect. It simply means data did not provide strong enough evidence. So, in short, p value helps us measure evidence, not certainty. It guides decisions, but it does not guarantee truth. Next, let's understand how to choose right test. One of the most practical question analysts faced is which test should I use? Answer depends on three key factors. Type of data you have, whether numerical or categorical, number of samples or groups you are comparing, and whether those samples are independent or related. If you are comparing mean of one sample to a known value, use one sample t-test. Comparing means between two groups, independent sample t-test. Same group before and after change, paired t-test. Comparing more than two groups, ANOVA. And for promotions or categories, chi-square test. Each test has assumptions like normality, equal variance, and independence that must be met for results to be valid. So, choosing right test isn't just about formulas, it's about matching your question and data type to the right statistical tool. Now, before we wrap up, let's highlight some common mistakes to avoid in hypothesis testing. Even experienced analysts make errors when applying hypothesis testing. Here are most common ones and how you can avoid them. Mistake 1. Confusing fail to reject with accept the null. Not rejecting null doesn't mean it is true. It just means there is not enough evidence to prove otherwise. Mistake 2. Ignoring practical significance. Results might be statistically significant but too small to matter in real world. Mistake 3. P-hacking. Running multiple tests until you get desirable result. This inflates your chances of finding false positives. Mistake 4. Using small sample with low power. When your sample is too small, even real effects can go unnoticed. Being aware of these pitfalls helps you make conclusions that are not only statistically sound but practically meaningful. Finally, let's bring everything together in quick wrap up and recap. So, to summarize, hypothesis testing helps us move from assumptions to evidence. We define our hypothesis, collect data, calculate probabilities, and make informed decisions based on risk and confidence. Along the way, we explore type 1 and type 2 errors, statistical power, p values, and how to choose right test. Remember, goal of hypothesis testing is not to prove something beyond doubt. It is to make data-driven decisions with confidence and clarity. We have learned how to test ideas with hypothesis testing. But what if you simply want to know how strongly two things are related? That's where correlation analysis comes in. And that's exactly what we will explore next. If you found this video helpful, hit like, share it with your data friends, and subscribe to Shital's Data Desk, where data meets clarity. Thanks for watching.